After the first set of United Nations life tables were developed, subsequently different life table systems were developed, of which one of the more influential were the life table systems put forward by Coale and Demeny originally in the year 1966 and then revised in the year 1983, called famously as the Coale and Demeny Regional Model Life Tables. These tables included 192 life tables by sex of observed mortality data from populations and pertain to several time periods. 39 tables from before the year 1900s, 69 tables from after the World War II, and these tables were also mostly from Western countries. The mortality patterns revealed were characterized into 4 types called the North, South, East and West, each of which had a characteristic pattern of child mortality, and the underlying patterns were largely corresponding to particular geographical regions of the populations from which the data was derived, and pairs of life tables by sex were generated for each level of mortality. Some of the limitations of the Coale-Demeny model life tables is that although higher on accuracy than previous tables, the number of non-European countries that were represented were limited, and it is also considered that the tables may not cover patterns of mortality existing in the contemporary developing world, with some well-documented patterns that lie outside the range of the Coale-Demeny life tables. It is still, however, widely used, and more can be found in the following module.
I am Dr. C.P. Prakasham, retired professor from International Institute for Population Sciences, Mumbai. I will be teaching about Coale and Demeny Regional Model Life Table, Module 30. In this module, we will be learning about Regional Model Life Table developed by Coale and Demeny, titled as Coale and Demeny Regional Model Life Tables. The Coale and Demeny 1983 Regional Model Life Tables, which were originally published in 1966 and revised in 1983. They were derived from a set of 192 life tables by sex from actuarial population. This set included life tables from several time periods, 39 from before 1900 and 9 from after the Second World War, and mostly from Western countries. Europe, North America, Australia and New Zealand contributed a total of 176 tables. 3 were from Israel, 6 from Japan, 3 from Taiwan, 4 from the white population of South Africa. Initially, 326 tables of each sex based on age-specific death rates over different geographical locations and time period were collected. From that, 192 selected life tables were derived from registration data and were subjected to very stringent standards of accuracy. The preliminary model life table, all the QX values corresponding to initial selected 326 life tables from each sex were arranged in descending order of each age. These values of the QX then were plotted as a function of order for each age and removed the erratic fluctuations by hand smoothing. Preliminary model life tables developed by putting mortality rates with the same rank. From the preliminary model life tables 326, the pattern and deviation of age pattern of mortality was measured as the difference between QX in the given table and QX in the model life table. The comparison model table was selected by the expectation of life at birth in the model life tables with the same QX of the life table at x equals to 0, 1, 5 up to 75. The median model life table was selected as the comparison table and the phi QX is denoted as phi QX to the power of m. From the median model life table, 192 final model life table by sex have been selected with the criteria that NQX minus 5QXM is minimal, that is m is model value. The underlying relationship identified for typical age pattern of mortality determined largely by the geographical location of the population and their pattern of deviations from previously estimated regression equation. Those patterns were called north, south, east and west. Each had a characteristics pattern of child mortality. The East model comes mainly from the Eastern European countries and is characterized by high child mortality in relation to infant mortality. The East model constitutes total of 31 life tables of Austria, Germany, the Federal Republic of Germany after the Second World War, and northern and central Italy, and some from Czechoslovakia and Poland. The North model is based largely on Nordic countries and is characterized by comparatively low infant mortality, high child mortality and low old age mortality beyond age 50. Countries: Iceland 1941-50, Norway 1956-80 and 1946-55 and Sweden 1951-1990. The South model is based on life tables from the countries of Southern Europe, Spain, Portugal and Southern Italy, and has a mortality pattern characterized by high child mortality in relation to infant mortality at high overall mortality, low child relative to infant and low overall mortality. Countries: Spain, Portugal, Italy, Southern Italy and regions of Sicily covering a period from 1876 to 1952. The West model is based on the residual tables not used in the other regional sets, that is, countries of Western Europe and most of the non-European population, and it is believed to represent the most general mortality pattern. Countries: all residual Western European countries. After identifying 4 age patterns of mortality among the observed life tables, QX values estimated by regression method as NQX equals to AX plus BX multiplied by C10 and log base 10 multiplied by 10,000 NQX equals to CX plus DX multiplied by E10. The pair of coefficients AX, BX, CX, DX were obtained by fitting the above regression equation. The pair of coefficients AX, BX and CX, DX were obtained by fitting above regression equation. From the above equation, depending upon one parameter E10, 24 values of E10 for females were selected so that they produce E0 values ranging from 20 to 77.5 years, increasing by 2.5 years. Same procedure is followed for males. Pair of life tables generated by sex were generated for each level of mortality. The pair of life tables with a female E0 of 20 was marked as level 1 and that with a female E0 of 77.5 became level 24. According to level and according to E0, model life tables of each region developed. In all 4 regions, 2 sex, 24 levels, that is 4 multiplied by 2 into 24 equals to 192, model life tables have been generated. This graph shows mortality curve in 4 model life tables for different mortality levels. You can see male, female and total mortality curve. On the left side, you can find the y-axis in terms of logarithmic values. Limitations. The Coale-Demeny model life tables had much higher standards of accuracy from the empirical tables. This demand, however, limited the number of non-European countries represented. The Coale-Demeny tables may not cover patterns of mortality existing in the contemporary developing world. There are examples of well-documented mortality patterns that lie outside the range of Coale-Demeny tables. To overcome limitations in Coale-Demeny regional model life tables, Demeny and Shorter found no number of tables within the family that adequately reflected in Turkish mortality experience, the Demeny and Shorter 1968. Although the North, South, East and West classification provides an additional dimensions, the uniparametric nature of each family still limits its flexibility. Example, a thematic report of mortality, part of the 2014 Myanmar population and housing census were carried out to estimate preliminary early age and adult mortality in Myanmar. As part of the process of estimating adult mortality with life tables, a smoothing out of the data on age, sex, death rates using life tables was needed. It was seen that the North model, Coale-Demeny model, was not suitable for males and females determined through the demographic package MODPAC. As a result, the North pattern was used for the smoothing process of urban and rural areas for each state region. A demographic package MODPAC is used to construct mortality estimates by indicating similarity indices by comparing observed age-specific mortality rates with United Nations and Coale-Demeny model life table patterns. In an article on the levels and patterns of mortality in Nepal, it was shown how, due to various data difficulties, indirect methods of estimation of mortality indices was needed using life tables as the Coale-Demeny model and compared with the United Nations models. Up to 1991, researchers have used the West model of Coale-Demeny, but the article shows how Nepal fits closer to the general pattern of the United Nations model using data on infant and child mortality rate from the Demographic Health Survey of 2001. The report reveals for CMR is 26.79, IMR is 67.35. For CMR is 24.94, IMR is 64.4. For CMR is 20.02, IMR is 56.7. The report indicated CMR to be 28.6 for IMR of 96.4, but the West model indicated CMR of 24.94 corresponding to the same IMR, a deviation of 3.66 per thousand. Similarly, the general model indicated CMR to be 26.48 corresponding to IMR of 64.4, showing that the CMR from the survey deviates from the general model by 2.12 per thousand. The general model United Nations thus has less deviation than the West model Coale-Demeny. Therefore, the general model is used to derive mortality indices. There are various limitations not discussed here.